Alright, so example 2 says to use synthetic division to divide those two polynomials. First thing is synthetic division is like part, it's not that big, part of a rectangle here. Okay? We're going to put a number on the outside right here. And we're going to put a whole bunch of numbers up here. The number on the outside, it's just like on the long division. It has to do with what we're dividing by. Well, we're dividing by x plus 2, aren't we? But I'm not going to put any x's in this problem. So I'm going to set this equal to 0 and solve. Or you can think of it as I'm taking the 2 away from the x. And remember we said anytime the number comes away from the x, it changes signs. So either way, we end up with a negative 2 to go on the outside. The inside is going to be the coefficients of our x's in descending order with every x from the largest exponent to no x accounted for. So if I'm missing like an x squared, I'm going to put a 0 there as a placeholder. So I'm going to take this problem here and I'm going to rewrite it up here above it, and then I'm going to pull its coefficients. So what is my largest exponent there? So I have an x cubed, and then do I have an x squared? No, but I'm going to have to put a 0 x squared there. I need a placeholder. And guys, we didn't encounter this on example 1, but you do the same thing with long division if something's missing, because you need it as a placeholder. All right, then do I have an x? Yeah, I have a minus 7x. And then do I have a no x? Yeah, that's at minus 6. It has no x. So I'm going to take the coefficients from this problem and put into the inside of my box there where I drew that circle a minute ago. What's the coefficient for this first one? A 1. What about my second term? And my third term? And my last term. And then under that negative 6, we're going to go down here to the leg of the rectangle there, and we're going to draw another little partial rectangle. This box right here is my remainder box. Whatever I get in there will be part of my remainder. So the first thing we're going to do every time is whatever the first coefficient was, we're going to bring it down. Now anything that gets put on that bottom row is going to get multiplied by whatever number we have on the outside there. So we're going to multiply that 1 by negative 2. So what's negative 2 times 1? Negative 2, and we're going to put that in the next column. Then we combine that column. What is 0 minus 2? And we put it underneath. But I put something else in that bottom row, didn't I? So what are we going to do with every number that goes in the bottom row? Multiply it by that negative 2. So negative 2 times negative 2 is positive 4. So let's combine them. What's negative 7 plus 4? Negative 3. It's in that bottom row, so we're going to multiply it by negative 2. What's negative 2 times negative 3? And then we combine them, and what do we get? 0. And so that's our remainder there. Okay, so my bottom numbers there are coefficients, just like the numbers at the top were coefficients. So let's think about this, though. When we started this problem, we were taking this x cubed and we're dividing it by an x. What is x cubed divided by x? X squared. So that means my answer is going to start with x squared. So I've got 1x squared. And again, my x's are going to go in descending order of the exponents. And these numbers on bottom are my coefficients. So I have minus 2x to the first, minus 3 that's not going to have an x, plus my remainder over What were we actually dividing by? Yeah, the x plus 2, okay? All right, so here's our answer, but I really didn't have a remainder, do I? So even though it's 0 over the x plus 2, do I really have to write it since there's no remainder? No. So we can simplify this just to be our x squared minus 2x minus 3.